a brand new Mahusive lathe from WH Lead to Beck Prosper in Dudley, and also a slightly smaller one, but I'm going to talk to Robbie about why they need this massive one, what parts they're making, and why they couldn't make those parts on anything. To make big fasteners and exotic materials, you need a big machine. That's why Beck Prosper have gone for a big lathe from WH Lead. It's the LTC 35CL, Robbie. Now, why have you got this part on it?
So this part is obviously a long fastener, and on the lathes that we do have, they don't have length of this machine, and they don't have the diameter that the spindle has. So, as you can see, the length we've got there, turning that over a long distance can be quite tricky.
Yeah, you've got to maintain a diameter over quite a long. Is it about a metre long?
And also we've got this portion there will go to grinding, so that has to be bang on there. We can't have any taper in it, otherwise we're going to struggle with the grinding. Now, the machines that we've got at the minute that are a lot older, they're a lot more worn, they're not as in line, whereas this new machine is way more rigid, so it's a lot more capable of machining a longer part accurately. I mean, so far through all of these, we've had no scraps, no errors, and there is absolutely no taper across the whole length. Everything's completely in line.
Absolutely no scraps on this machine?
No, nothing. We've had, not of this job.
Right, okay, not this job, yeah, no,
job.
Okay, fair enough.
So
do you get a lot of these jobs where you need this length on the bed?
We have had them in the past, but we haven't been able to take some of them on due to the fact that we didn't have as many large machines to do this kind of work for.
So you had to turn those jobs down?
Yeah. So effectively, we were losing out on business. So adopting this machine, we've been able to take on larger jobs. We've had more capacity because now we're able to have an extra machine doing this kind of work. And it's a lot more reliable. Knowing that you've got a machine that's actually in line, everything's trued up, the chuck, tailstock, the turret, everything is fresh, brand new. So it makes it a lot easier when you're doing work.
What kind of operations are you doing on this machine then? Can you explain what you need to do for this part?
So the basic operations to start with was we had this, originally this was a complete piece of bar. So we'd faced and centred one end. That was the first operation altogether. And the second operation was to hole on this diameter and turn all of this.
There's quite a lot of material to take out here.
It is. Believe it or not, because it was, because of the machine's true, there was absolutely no vibration, so it was almost silent when it was turning.
No vibration with this?
None at all.
I guess using the older machines, you were used to having to deal with vibration every day.
You'd be using, that might not be quite in line with that, so then you've got that force reacting with the tools cutting it, so you get vibration, whereas this, everything's in line. There was absolutely none. Well, you can see by the finish,
it's a smooth, it's a beautiful part, isn't it?
Absolutely no chatter marks or anything on there. So yeah, so the actual operation was to come down, turn all of this, and then we left that as a rolling diameter, that as a rolling diameter, and then they've been sent elsewhere to have a rolled thread, and then they've come back to us, obviously, we have to face off that centre on that end. That'll be our next operation.
So it's got no hole in the end of it?
Yeah, it's got a small hole in the end of it.
Brilliant. So obviously there's other operations you're doing to these parts outside of the machine tool. So you need to make sure that the first thing you do, which is cutting out the machine, is right
We need to make sure. That's it. If we make that incorrect, then it's failed for every other operation. So far, there's been no problems with them, so they've all been rolled, they've come back, and they're okay.
So do you feel like you can rely on this machine moving forward for these kinds of parts?
Yes, absolutely. Yeah, definitely.
But there's absolutely no hesitation there at all.
Yeah.
What are the materials? So this is an EN9, you're saying, kind of?
L43, so it's the same kind of thing. It's relatively soft. We can turn all sorts of. At the minute, we've got some Inconel 718 double-ended studs that we were running off at a previous time, and it's been doing those okay. And obviously, it's a lot harder material. It breaks the inserts quicker, but still, we've had no issues with it. So,
do you find it's got the power to push through and make sure you chip those more difficult to chip?
Yeah. I mean, a lot of those materials are difficult to get to chip, but the torque on the machine, you can get it to chip. You can get a lot higher feed rate through it. Obviously, with the larger spindle diameter means you can't quite get the speed, but you can definitely get the depth of cut. Or you can see the size of the turret.
Absolutely no problem. And you can trust this machine?
We can trust it. It's reliable. You can put the part in once it's set. Your tools are set, and obviously you've got the option with the manual guide, the easy guide, and you can put your tool data in. So when you do change, and you think, oh, I want to put a 1.2 in or a 0.8 insert, and you can change the geometry on there, and then whatever program you'll
compensate for that as well.
For it.
That's fantastic. So easy to use, even though it's such a big lathe. Leadwell do fantastic lathes for complex parts, difficult exotic materials. Check them out from WH Lead.